This is the solution to question 2 for HAP 725, Statistical Process Improvement. The solution was provided by Dr. Maria Urio. Nursing home and hospital administrators implement many initiatives to reduce falls. This problem shows how these initiatives can be measured and evaluated. We're going to be preparing a risk-adjusted control chart for data on falls in a nursing home. The problem provides you an Excel data file. You are to extract that data file and make sure that you remove any merged rows so that you have a data file that you can work with easily. The next step is to import the file into Python. You begin by importing the libraries. We're going to be using Pandas, NumPy, and the matplotlib.pyplot. And then, of course, then you have the statement for reading the file into Python. And this is the output of the file that we've just read into Python. In this step, we're dropping the cases column, and the table on the right is the resulting output. To continue working with this data, we need to transpose it. So in this step, we're transposing the data frame and using the data.t and putting that data frame into the df_t new data frame. In this step, we're adding the time period column from time 1 all the way to time 9. And this is because we can't really use the time 1 to time 9 on the left. That is an index. So we want a time period that we can use in our calculations as we move. We are renaming the columns within the df_t. We're giving the columns new names. And then, of course, for column number 21, we're changing that name to reported falls. We now need to count the number of cases by each time period. And the resulting count, as you can see on the right, took into effect the reported falls in the time period column. these two columns, reported false and time period, need to be excluded, and they can be excluded in the next step. In this step, we're excluding the reported false column and the time period column from the count column so that we have a final count indicated on the right. We're dropping the count column since we don't need it anymore. To calculate the observed rate, we divide the reported false column by the final count column from the df_t data frame. And the results of the calculation are displayed on the image on the right. The formula on this slide shows you how to calculate the expected rate. The expected rate is determined by finding the average from the values within the CO column all the way to the C20 column. In order to calculate the expected deviation, we need to create a new data frame. And in this slide, we're creating a new data frame called DF2 that is made of column C0 all the way to column C20 from the df_t data frame. The first step in calculating the expected deviation is to determine the risk. This slide shows you how to do that. The second step for determining the expected deviation is to determine the sum of risk. This slide shows you how to determine that. The third step for determining the expected deviation is to calculate the square root of risk. And then how to do that is shown on this slide. In this step, you need to add the square root of risk column from the df3 data frame into the df_t data frame. The expected deviation can then be calculated by dividing the square root of risk divided by the final count. We need to add the t-values into the df_t data frame, and we need to be sure that the degrees of freedom correspond to the values within the time 1 to the time 9 data rows. So the degree of freedom of 17 has a t-value of 2.11. The degree of freedom of 20 has the t-value of 2.086. You are now ready to determine the upper control limit and the lower control limit values. And the steps for doing that are shown on this slide. The control chart indicates that the decline in the observed rate over time shows the initiatives implemented by nursing home administrators to reduce the number of falls is working.